Okay, topic today is binary search trees. Before we go into a binary search tree, we should probably talk about what a binary tree is. Um, a binary tree is a data structure containing a node and two child nodes. Their first node will be called the parent node that points to two children nodes, and the children nodes themselves can have two children of their own. And the children will be known as a left child or right child. So you have a root and then a left child and a right child, and you bring that out and you're getting a tree. Um, and a binary tree becomes a binary search tree when it follows the binary search tree or the BST property, which is that every left node is less than or equal and every right node is greater. And the less than the equal side can be on the side depending how you're going to make it. So you'll know if you go left, everything's going to be less, and you go right, and everything's going to be greater. Um, for example, with the binary tree, I've created a binary search tree. Let's see if you can see it. Um, so basically, I have at the root, I have a 2, and then to the left, I have one node, which is 1, and to the right of the root 2, I have 3. 3 has another node, 7, which is on its right side, and 7 has two nodes, one on its left and one on its right. On the left, it has 5, and on its right, it has an 8. This helps you out with search algorithms and simple things like find min and max real easy compared to like a linked list. Like for the min, you go all the way left, and you go all the way left in my BST, and you get 1, which is the min, and then you go all the way right, and you get 8, which is the max. So the principal distinction between a linked list and a BST is that the structure of the BST is determined by the content of the key fields to provide efficient access to specific nodes. Um, the content-specific ordering is a BST allows it to satisfy search algorithms more efficiently than the ON complexity of a linked list. Because linked list, you just have to go, worst case scenario, you go through the entire linked list to the very end to find what you need. With the BST, you don't need to. You just need to, excuse me, to find the specific key you're looking for. One only needs to make a comparison on each node, search left or right, and you can perform binary search, just like you do on a sorted array. Binary search tree is one in which the left and right pointers of each node point to subtrees that are roughly the same size. I'm sorry, a balanced binary search tree. The same size within some fixed constant. Excuse me. The longest path in the tree from the root to a leaf is proportional to log of n. So if a tree of size n has O log n height, then the tree is a balanced tree. A tree is said to be perfectly balanced if it has a minimum possible height. Examples of a balanced binary trees are a tree in which subtrees of every node are proportional in size, a tree in which subtrees of every node are proportional in height, and a tree in which subtrees of every node have the same height to within a constant difference. Note that these conditions must be enforced by some mechanism. A binary search tree can be defined formally as follows. An empty/null tree is a valid BST. A node is the root of a valid BST if its left pointer points to a BST in which all nodes have keys that are less than its own. And it has a right pointer that points to a BST in which all nodes have keys that are not less than its own. So the main reason you would use a BST over a linked list is the easy access to any element in the list. So, if you had a linked list 1 through 8, you want to find the max element, you'd have to search through the whole thing. We're, of course, talking about a simple linked list where you just have a pointer to the head and you have to go all the way to the end to find 8. So the min is easy because if it's sorted, you know that the first element's the min. You get that in O of 1 time, and then you go to the n to get 8, which is O of n. But with the BST, it allows you to use the binary search algorithm, which is really efficient, and you get it in log n times. That's the benefit of the BST. They have the same operations as linked list, as insert, remove, find. So that's the reason you would do it, is be able to use your binary search algorithm. Well, that's a little quick look at BSTs. Thank you for listening, and have a good day.